and bring in Dr. Elspeth MacRae, who's also joining us from New Zealand. Dr. MacRae is going to talk to us about a circular bioeconomy. So we've gone from the OHA compass now into the circular bioeconomy.
Hi there. Okay, and I'm sitting in Rotorua, which Amanda's just been talking about, so kind of links us really nicely. I need to share my screen, so we need to just make sure I can do that, and I should be fairly quick, I think. Oh, it is.
Here we go, it's coming. If you just want to put it on full presentation mode.
Yep.
Wonderful, that's
there
perfect.
Now.
Thank you.
Okay, so I've been listening yesterday and again today, and there's been a lot of commonality from everybody and a lot of thoughts and sort of concepts. And what I think I'm probably going to show you is that the disruptors are all available right now. They're all there, and I'm probably going to be quite different to other people and just give you examples of them as I go through this. And I hope you can see how they can all be used for all the things that people have talked about. And so if we look at this now famous planetary boundary picture, I wonder if we drew it again in 2025, what it might actually look like. So I'm going to talk disruption, and because we all have been talking disruption, and disruption's been coming for a long time, and quite a lot of people have been trying to avoid disruption or prevent disruption, but it's there. And way back in 2013, McKinsey did a document on it, and since then you can see a huge list of things, and there's many more of changes, of opportunities that have appeared. So what I'm going to do is I'm going to walk through, first of all, in a very simple language, what is a bioeconomy? Secondly, about circularity. Number 3, I'm not going to say a lot about it, but everything pretty much that people have been talking about so far is about evidence and tracking and trustworthy tracking and real tracking. And tracking is more than just, I've built a house out of wood and I've tracked the wood from the forest and into the house. It's actually a lot more. And when you start doing it in companies, they have to think about what is a consumer doing, and they have to add that in, and what about all the components that came together for them. Then I'll briefly mention biomass, because we've got lots of opportunities there, new biomaterials, new manufacturing, and I'll finish with urban design. What's basically different about a bioeconomy that people have been reacting against? It's actually centralization. And it's centralized ownership, centralized benefits, centralized manufacturing, and economies of scale. And so that's what people in today's world talk about. And what a bioeconomy does to disrupt that is it's distributed. The benefits are distributed. You can actually do things with technology these days that means you don't have to centralize. And the scales tend to be a lot smaller, and they're additive. How do you do? Circularity originally came popular from the MacArthur Institute and the development of that thinking. And it relies hugely on traceability, also performance, many, many cycles, generations of time. So you could be thinking 100, 200 years when you're thinking about your circularity. And again, disruptions in the whole manufacturing side. And I've got an example here for you. I've said it's happening in New Zealand, and actually it is. So you have carbon dioxide and water, atmosphere all around us. Trees, for example, can capture both the carbon dioxide and the water. They take it and turn it through photosynthesis and other processes into sugars and polymers. Then you have microbes naturally occurring in the environment that take those sugars and polymers, and they make a storage material, just like starch, just like glycogen for us, only it's a plastic, it's a bioplastic. And there are lots of these, they're all over the world, and there are a lot of them, and they evolve. And then you can take the bioplastic out of those microbes, and you can make various plastic products. And you can see one there with a hand, and that's made from in New Zealand with a PHA made from tree sugars. And on the left-hand side, you can actually see then you can take that and you can take some waste streams from processing kiwi fruits to juice. So you can take the skin and you can create an edible, biodegradable spoon that helps you to have a picnic eating your kiwi fruit. All of your bioplastics, because they're PHAs, can be controlled in their degradation. And in their degradation, because it's a natural process, they regenerate carbon dioxide and water. So that's circularity in a nutshell. Now let's look at another development of circularity, and this is urban mining. And this is Mint Innovation. It's a company out of New Zealand. And what they are doing is actually mining all of the metals that we throw away. And they're using microbes again to concentrate the metals so that we can reuse them. And you can see some of their figures there, and they just won a Technology Pioneer Award at the World Economic Forum. Biomass, major resources. The planet's been doing biology a lot longer than we've been around. And biology normally is 10 times, well, it's nearly 100% efficient. It does things that we can't even begin to match. We can actually modify, if you see on the left hand side, it's a whole lot of foods and various resources that mankind has decided to focus on, but we can actually modify those ourselves, or we can allow the planet, the environment to modify it. A tree is really just a factory. All plants are really just factories. And you don't have to think about a tree as just being a tree that you take timber out of all the time. You can actually think about it more like bamboo, more like cropping, and actually harvest it the same way and use it and replant and recycle. And this is a picture from Argentina, where you've grown trees for 5 years and you harvested them to use as biomaterials. And you can see there's a whole lot of waste that we as humans are pretty good at generating down the bottom, but all of those are usable. New biomaterials, so they can be either substitution or they can give us some new performances, which is even better. So you can see that we can replace asphalt on the roading systems with lignin from trees. And you can see this vehicle, idealistic vehicle. If we actually use all the technologies and all the things that are available to us, our vehicles don't need to be full of metal, because if they're automatically driven and we don't get behind the wheel for them, you don't have to have the protection there. You can make the whole thing out of bio-based materials, and you can have it, for example, generating its own energy from the sun, etc., etc. So you can absolutely, completely reconceive of transport vehicles for people. In the middle, you've got some biomimicry or application of biomimicry, and this is from a designer of lights. These lights were actually in the Abu Dhabi expo, just finished. And they're made from the bioplastic that I showed you and talked about before, and paua shells, which is a shellfish in New Zealand that has structural color. And the advantage of structural color is that it doesn't fade. So all the dyes that we've actually been extracting and using fade, but structural color does not. And so the paua shell gives you beautiful structural color that will be there forever. So again, it's an adoption of nature. And then when we talk about these engineered woods that are building us our tall buildings, you've got to remember that actually some of those are 50% glue, because you're gluing the bits together to get the strength. Well, the glues all need to become bio-based, not petroleum, and a lot of them are still petroleum. Then you come down to concrete. Well, you don't have to just have concrete. You've got things like hempcrete, and that can do much better job of insulation and lightness. And then at the bottom, you can see strength using these engineered materials without steel. So they're all examples. Again, new biomaterials, you can actually sit there and say, well, bark, at the moment, we don't use much of the bark from a tree when we're currently taking out the wood. But there's actually a lot of bark, and it's got a lot of valuable materials in it. So suberins, you can see there, like cork. You can see tannins. You can use those tannins to make the glues that glue the wood together, and so on and so forth. And you can go right through to medical applications. And the same with cellulose. That's one of the main features of the trunk of a tree. It can make many, many, many different things, and people are just, there's an explosion in ways you can use cellulose. a natural biomaterial. So what this means, and this is where a lot of resistance has been coming, is rethinking industry. And that's distributed, I'm going to give two examples, distributed manufacturing and 4D printing. So it's bio, by definition, in this talk, customized, just in time, and local added value. So you've got mobile manufacturing. And so the top two factories there, one of them's a chemical processing plant, and the other one processes grass into new compounds. The one at the bottom is actually a mobile pilot plant, and it processes human waste and makes fertilizer and energy. And on the right, you can see an application with cassava waste in cassava, where instead of gathering all of the waste and taking it to a factory and doing something with it, you use these mobile plants to go around and actually do the manufacturing all locally, and you actually keep the wealth within those communities. 4D printing is an explosion that many people have probably not really realized. 3D printing is printing just in time, less wastage. You can use bio or non-bio. There's a lot of plastics in it, and metals, but it doesn't have to be them. And what happens with 4D printing is you actually take what biology does and you say, can we get our materials that we've created to do what biology does? So respond to environmental cues. And you can see down the bottom two different fiber-based bioplastics, and they've added water. So when they're dry, they're one shape, and when they're wet, they're in another shape. But there are many other things you can do. Same with color. And we've actually got an example there of using stem cells and thinking about, can we use carbon fibers we use from lignin to make actuators to make these little robots type work. So huge opportunities in this area. And then we come to housing, and I'm sure you all know that there's been a bit of an explosion. It's taken a long time to come in 3D and just developing 4D printing of housing. And again, the advantages of reduction in wastage while you're manufacturing. You can see two of the pictures from Floriade in the Netherlands just recently. And you can use a range of materials. It can be sand, it can be clay, it can be fibers, there can be responsive materials like the living mycelium, etc. So your imagination is really all you need. And then I'm going to finish now with the biggest, messiest slide, which is all of this comes together in these urban redesigns and whole system thinkings. And Kashiwa Noha, for example, in Japan, one example. But one of the key examples I really wanted to emphasize, because I think people forget about it, is the designs for living on Mars and the designs for living in the space station, because they have to use everything biological that they can, which is the humans and what the humans do. They can add biology, they have to recycle, recycle, recycle. And the thinking that's sitting in there should be inspiring this thinking for our own environments on the planet. And so it's time to use disruptions much, much better than we have done. And I just say thank you very much for listening. And I want to acknowledge some of the people who've done some of the work that I've talked about. Thank you.
Thank you. Wonderful. Thank you so much, Dr. MacRae. And hopefully we will be able to come back with a few questions. I love the last slide around using the design on Mars in order to understand how we can better prepare ourselves for today, assuming that actually we think that planetary survival is still the most important and not actually moving to Mars, which some are pretending escape is the only route. And I would say deal with it and let's make sure we save this planet that we call home.